Okay, पिछली classes में what all have we done? We did the properties which were showing periodic, you can say periodic. What can you say? Change or gradual change when we were moving from one side, from the left hand side to the right hand side of the period, or when we were moving from top to bottom in a group. Right? Now we had studies which were the properties which we studied. The first one was atomic radius. The second one, atomic radius, we said that as we are going along the period, it keeps on decreasing, and along the group, it keeps on increasing. ठीक है? फिर इसमें anomalous जितने behaviors थे वो भी हमने discuss कर लिए थे. Second was ionization energies. Ionization energies that is increasing along the period and decreasing down the road. ठीक है? फिर आगे electron gain enthalpies. Electron gain enthalpies also was becoming more and more negative as we were traveling along the period, and they were becoming less and less negative when we were traveling down the route, except for chlorine and sulfur, which showed anomalous behaviors. ठीक है? फिर then we did after electronegativity, we did the next point, which was the electron gain enthalpy. We did the next point, which was electronegativity. Electronegativity was the tendency to attract a shared pair of electrons towards itself. Along the period, if we are moving, the electronegativity that was increasing, and down the group it was decreasing. Such that fluorine जो था, that was the most electronegative element of the periodic table, and cesium was the least. Now, apart from these, there are certain other properties, small properties, which we will discuss today. The first one, which we are going to discuss, that is the atomic volume. ठीक है? अब atomic volume जो है, it is going to increase down the route. We know that volume that is going to depend upon the atomic radius or the atomic size. So down the group, because we are saying that one atom that is equal to what? It is a sphere. So volume that is equal to 4 by 3 pi r cube. Okay? So volume is directly proportional to the radius. As we keep on going down the group, right? We are going down the group. In this case, the atomic volume increases. Why this atomic volume is increasing? इसलिए increase कर रही है due to introduction of a new principal shell. ठीक है? So due to introduction of a new principal shell, the volume down the group that will keep on increasing. When we going from left to right in a period, we say that the atomic volume that varies cyclically. ठीक है? That is going to vary cyclically, which means that it first decreases for certain elements. It first decreases for certain elements, ठीक है? और उसके बाद it becomes minimum in the middle. Middle में जाके minimum हो गई, and then increases. And then increases. ठीक है? So what is happening? First it is decreasing, reaching to a minimum, and then it starts increasing. Why does this happen? This happens because of two factors, right? The first factor is atomic radii decreases. We know that when we are going along a period, the atomic radii decreases. Why does atomic radii decrease along the period? Because of increase in nuclear charge. ठीक है? And second is number of valence electrons increases. As we are going along the period, number of valence electrons also increase. So these are the two factors. Now in order to accommodate all the valence electrons, see what is happening when we are going along a period, the shell size is same. For example, if we are talking of the second period where we are filling up the second, n is equal to 2. The shell size is the same, atomic radius is decreasing, but number of valence electrons, that is increasing. So in order to accommodate all the valence electrons, the atomic volume that is going to increase. So initially it is decreasing, ठीक है, minimum तक पहुंच जाएगा. Decrease क्यों कर रहा है? Because atomic radii is decreasing. But when we reach the middle, say we are reaching carbon. So carbon has 4 electrons in the valence shell. उसके बाद वो 5 हो जाएंगे, 6 हो जाएंगे, 7 हो जाएंगे, 8 हो जाएंगे. But the shell is the same. तो उन सारे इलेक्ट्रॉन्स को अकोमोडेट करने के लिए एटॉमिक वॉल्यूम को इंक्रीज होना पड़ता है, राइट? सो एटॉमिक वॉल्यूम जो है दैट इज मैक्सिमम for francium. Francium has the maximum value of atomic volume. ठीक है? फिर उसके बाद सेकेंड प्रॉपर्टी जो आ जाती है that is density. Density we know that is equal to mass upon volume. Okay. Now what is happening to the volume? We are over here, we are talking of densities of the solid state only. Okay, what is happening to the volume? You can see down the group the volume is increasing. Along the period when we are talking of, it is first decreasing and then increasing. Depending upon that, if we are comparing the volume of solids. So at first density increases gradually when we are going from left to right. Density will increase in a period, becomes maximum and then starts decreasing. ठीक है? And central members में वो सबसे ज़्यादा होती है, right? The same pattern, inverse pattern of volume. Volume में क्या हो रहा है? It is first decreasing, so therefore density will increase, right? Reaches a maximum and then henceforth it will start decreasing. Okay? Now we say that in solids, osmium has the maximum density. Osmium has the maximum density, and in case of liquids, mercury has the maximum density. ठीक है? Then the third property which we are going to discuss, that is melting and boiling points. Melting and boiling points. The melting and boiling points, they vary inversely with volume. So volume is inversely proportional to melting points, which means कि all the elements which have a high value of volume, they are going to have low melting points. ठीक है? अगर वॉल्यूम ज्यादा होगी तो जो melting points होंगे they are going to be less. Is it clear? And vice versa. If the volume that is going to be low, then the melting point that is going to be high. Right? Now, in case of a period, if we are talking of, in case of period, the melting point, because what is happening to volume? Come back here. It decreases. So if it is decreasing, the melting points will increase. Okay. So in a period, melting point increases, reaches a maximum, and then starts decreasing. And then starts decreasing. ठीक है? So along a period, this is the trend of the melting point. फिर boiling points जो है, they also show almost the same trend. Okay. Now when we are moving down the group, The melting and boiling points, they show a regular gradation, but the gradation is shown according to the groups. Like for example, when we are talking of alkali metals, in case of alkali metals, the melting and boiling points decrease on moving down the group, right? So decrease on moving down the group मतलब जो हमारे पास लिथियम है उसका मेल्टिंग पॉइंट सबसे ज्यादा होगा, फिर उसके बाद सोडियम, फिर उसके बाद पोटेशियम, फिर उसके बाद रुबिडियम और फिर उसके बाद सीजियम. ठीक है. Whereas when we are talking of halogens, in case of halogens, an opposite trend is followed. The boiling points and melting points, they keep on increasing down the group such that fluorine की सबसे कम, फिर उसके बाद chlorine, bromine and iodine. Right? So it depends upon the group which we are talking of. Okay. Now in this case, tungsten has the maximum melting point. Tungsten has the maximum melting point of 3683 Kelvin among the metals. Among the metals, tungsten has the maximum melting point, and amongst the non-metals, carbon has the highest melting point. Amongst the non-metals, carbon has the highest melting point of 4000 Kelvin. ठीक है? Then the lowest melting point is that of helium. Lowest melting point is that of helium. Helium has a melting point of 3 Kelvin only. ठीक है? And whereas metals like cesium, gallium and mercury, cesium, gallium and mercury, they have a melting point of approximately 303 Kelvin. Right? Mercury, that is mercury in fact. Just talk of mercury over here. Mercury has a melting point of 303. Gallium जो है, you know that it has the lowest melting point amongst metals. जैसे you will keep it in your hand, it is going to melt. ठीक है? फिर उसके बाद हमारे पास आता है periodicity in chemical properties में. The next property which we are going to study, that is valency. Valency. Valency basically it is the combining capacity of any element. It is the combining capacity, right? And the electrons present in the outermost shell, they are known as what? We already know this. We already know this, that they are known as valence electrons. And it is the valence electrons which are going to participate in a chemical reaction. ठीक है? Bonding में भी valence electrons participate करते हैं, reactions में भी valence electrons ही participate करते हैं. Okay? Now the valence electrons, when we are talking of when we are going along the period in representative elements, the valency increases till the center and then decreases. Then decreases. Whereas when we are going down the group, the valency does not change. Down the group, valency remains same. In case of D block elements, the elements show variable valency, or we also call it as oxidation state. Right? They show variable valency. Like for example, we have iron, right, which shows a valency of Fe2 positive and Fe3 positive. But there are certain other metals, when they form oxides, they show a lot of variation in their valencies. Just for example, when we are talking of manganese, so manganese can form MnO, right, with a oxidation state of +2. It can form MnOO2 with an oxidation state of +4, and it can also form Mn2O7 negative, 2 negative. 2 negative की negative? Negative. यहाँ Mn2O7 ही लिखो, ठीक है? Mn2O7 with an oxidation state of +7, right? Now, amongst the D block elements, osmium shows the maximum oxidation state of +8. Now, in case of the representative elements, we have two different scales to show the valencies along a period. Representative elements कौन से हुए? The elements which belong to S and P. Right? So when we're talking of representative elements, we have two scales. The first one that is known as the hydrogen scale. So let's see how the valency that is varying on this scale. We have the first member, we are taking the third period over here. We have NaH, ठीक है? फिर उसके बाद we have MgH2, we have ALH3, ठीक है? फिर उसके बाद SiH4, PH3, H2O, H2S, and then HCl. Right? So this is the hydrogen scale. Now let's calculate the oxidation state of sodium over here. It is going to be +1, magnesium +2, aluminium +3, silicon +4. Over here now it goes down to -3. ठीक है? और यहाँ पे कितना होगा? -2. और यहाँ पे कितना होगा? -1. Right? So the valency it is increasing to +4 and then it is decreasing to -1. The second scale which we have, that is the oxygen scale. अब oxygen scale में बनाएगा same period we are discussing Na2O, NGO, Al2O3, ठीक है? फिर उसके बाद SiO2, P2O5, राइट? P2O5 के बाद आ गया हमारे पास सल्फर के साथ सल्फर ट्राइऑक्साइड एंड Cl2O7. So let's see over here the valency is +1, +2, +3, 2 2s are 4, +4, 5 2s are 10 divided by 2, +5, +6 and +7. Right? So on the oxygen scale, the valency along the period that is increasing from 1 to 7, whereas on the hydrogen scale it reaches a maximum at the center with +4 and then it decreases to -1. ठीक है? Clear हो गया? So then we have the nature of oxides. Nature of oxides. I have already told you that all the metals they form basic oxides and all the non-metals they form acidic oxides. ठीक है? और जितने भी metalloids हैं they are going to form amphoteric oxides. So when we are talking of nature of oxides, we say that in a period the nature of oxides shifts from basic character to acidic character. ठीक है? जैसे for example, we are again taking the second period only. We have Na2O, we have MgO, फिर उसके बाद Al2O3, SiO2, ठीक है? और फिर उसके बाद P2O5, SO3 and Cl2O7. As we are going from metallic to non-metallic character, in a similar manner, the strength, acidic or towards the acidic strength. So sodium oxide, that is strongly basic. Okay, Na2O is basic, strongly basic. MgO is basic. Then Al2O3, that is going to be amphoteric, right? Al2O3 is amphoteric. Then this is SiO2 is weakly basic, because silicon now becomes a non-metal. So it is going to be weakly basic. Not basic, acidic. Weakly acidic. Then P2O5 is acidic. SO3 is strongly acidic. And Cl2O7 is also strongly acidic. So we are going from a basic behavior to acidic behavior with the center amphoteric behavior of Al2O3. Right? And when we are going down the group, the basic nature increases and the acidic nature decreases. Like for example, if we are talking of the second group, the alkaline earth metals. So alkaline earth metals में the first member, that is beryllium oxide, ठीक है? फिर उसके बाद आ गया magnesium oxide, magnesium के बाद आता है calcium, calcium के बाद आएगा strontium and barium. So when we are going down the group, because the metallic character keeps on increasing, therefore basic strength increases. ठीक है? Now when we talking of, this was the first condition which we have taken, this is the second condition. The third condition we are going to take is, because you generally get a question like this to compare the acidic and the basic character. ठीक है? So this was the first aspect. As the non-metallic character increases, the acidic character also increases. As the basic character increases, as the metallic character increases, the basic strength is also going to increase. Now, if we are comparing the electronegativity, okay, so we say that as electronegativity increases, तो क्या होगा? Our acidic strength that will also increase. Oxides की जो acidic strength है, acidic strength increases. Right? That you can see over here also. Silicon, that is, when we are talking of the electronegative character over here, chlorine is going to be the most electronegative amongst all. And therefore, chlorine का जो oxide है, that is going to be most acidic. Right? And when there is a number of oxides, when there is a number of oxides an element is making, then the acidic character increases with increase in percentage of oxygen, right? Like for example, we know of nitrogen. Nitrogen forms 5 oxides, right? So we have nitrous oxide in +1 oxidation state. Then we have NO. Then we have NO2. Then we have N2O3, and we have N2O5. Okay. Now, as the percentage increases, let's put NO2 after N2O3 because the percentage is more. Okay. Now, as the percentage is increasing down the group, we are talking over here, nitrogen forms 5 oxides in 5 oxidation states. The acidic character will also keep on increasing, right? So, acidic character increases. Have you understood? So, as the oxidation state is increasing or percentage of oxygen is increasing, the acidic character is also going to increase. Now, there are 3 oxides which are neutral in nature. The first one, that is carbon monoxide. The second one is nitrous oxide. Third one is nitric oxide. ठीक है? And also for that matter you can also put water. All these oxides, they are going to be neutral. There are only these four oxides present which are neutral in nature. ठीक है? Clear हो गया? Okay. Then we go on to the nature of oxyacids. Nature of oxyacids. Oxyacids, they are when we talking of non-metals, right? When we talking of non-metals, then the strength of oxyacids increases from left to right. For example, if you're talking of the second period forms the following oxyacids. The first one, that is H3PO3. The second one is H2CO3. ठीक है? And the third one is HNO3. Now we are going from left to right. The acidic strength that is going to increase. These are the type of questions which you generally get. Increase in acidic nature. Right? Arrange the following in order of increasing acidic strength. Yeah, which of the following is true or false? So this is which of the following is correct, which of the options are correct. So if they've given it in the bracket as increase in acidic strength and they've given it like this, then it is correct. But if they've written decrease in acidic strength, then that is going to be incorrect. ठीक है? फिर second period में इस तरह से, third period में भी थर्ड पीरियड में भी जो फर्स्ट बनाएगा ये बोरोन बनाता है, फिर एल्यूमिनियम नहीं बनाता है ऑक्सीएसिड्स, फिर बनाता है सिलिकॉन. सो H2SiO3, ठीक है, H3PO4, H2SO4 and HClO4. Again, there is going to be increase in the acidic strength. HClO4, that is the strongest acid node. ठीक है? HClO4 is the strongest acid node. Now, in a group, this was a longer period. Let's discuss of a group. We are talking of the fifth group. The nitrogen. Fifth group क्या? You can say the 15th group. ठीक है? 15th group, which is the nitrogen family. Nitrogen family में we have the acid forms, they are HNO3. Then there is H3PO4, right? And then there is H3ASO4. The acidic strength down the group, that is going to decrease. HNO3 amongst all these three is the strongest acid. ठीक है? फिर उसी तरह से we go to group 17, the halogen family. In case of halogen family, we have HClO4. Fluorine does not form an acid like this. Then we have HbRO4, and we have hydroiodic acid, HiO4. Amongst these, again the strength that is going to decrease. ठीक है? So HClO4, that is going to be the strongest acid, right? Now when we talking of only acids of fluorine, the oxyacids of fluorine, oxyacids of fluorine जो बनती है, that is HClO, HClO2, HClO3 and HClO4. Amongst these, the acidic strength increases when we are moving from increases when we are moving from HClO to HClO4. ठीक है, strength भी increase होगी, stability भी increase होगी, oxidizing nature decrease होगा. So strength increases, stability increases, oxidizing nature decreases. ठीक है. Then next we go on to nature of hydrides. Nature of hydrides. Now, nature of hydrides, in a period when we are talking of, they become from weakly basic to strongly acidic. ठीक है? So along a period we have NH3, then we have water, ठीक है? And then we have HF. This is the second period, right? Over here, this is going to be weakly basic. This is neutral, and HF, that is going to be weak acid. Then let's go to the next group. We have PH3, H2S, and HCl. ठीक है? So यहाँ पे this is a very weak base. Very weak base. PH3, that is going to be a weak acid. Sorry, H2S is a weak acid, and this is a strong acid. Now you can also compare down the group from here only. NH3 is weakly basic. And PH3 is very weak base. So down the group, the basic strength that is going to decrease. Hydrides ka down the group, the basic strength that is going to decrease. Over here, we are moving from neutral to weak acid. So the acidic strength that is increasing. ठीक है? और over here we are again moving from a weak acid to a strong acid. So the acidic strength that is going to increase. So we're talking of halogen acids alone. So halogen acids would be what? HF, HCl, HBr, HI. ठीक है? In this case, the acidic strength increases. So HI, that is going to be the strongest acid amongst all of these. Stability, that is going to decrease. And reducing character increases. Reducing character decreases. Sorry, increases. Increases. Okay? So this is about all of this chapter. Now there's only one topic which is left. Anomalous behavior of elements of second period. Elements of second period. So second period of elements, they are the first elements of each group, right? The second elements, they are going to be which? The elements of the second period, they are going to be lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. These are the elements of the second period, and of course the noble gas also. But over here we are only restricting ourselves to fluorine. Now we say that all these elements, being the first elements of their respective groups, they show different properties than the rest of the members of the groups. Okay? Now why this is happening? The reason behind this, that is going to be that they are the smallest amongst all. So they have the smallest size. Okay. Second, they have highest ionization energies. Okay. Third, they have high value of electron gain enthalpy, or on the contrary you can write another one which is absence of vacant d orbitals. Absence of vacant d orbitals, and also high value of electronegativity. High value of electronegativity. So these are the four reasons because of which the elements of the second period, they show anomalous properties with respect to the rest of the members of the group. Okay, so with this we finish our chapter number 3. We would be starting chapter number 4 in our next lecture. Okay.